What if I told you that an Arduino board can play Snake using pathfinding algorithms? It thinks through moves, calculates optimal paths, and sometimes even surprises you with its decisions. Today we're diving deep into how I used an Arduino and some clever programming to build an intelligent snake game. Stick around. By the end, you'll see why this isn't just another blinking LED project. Well, welcome back to the channel. I'm Marat, and today we're building something that combines classic gaming nostalgia with modern programming techniques. This isn't your typical Arduino tutorial. We're going to explore pathfinding algorithms, game decision principles, and hardware optimization, all wrapped up in a project that's genuinely fun to watch. So, what exactly are we building? This is a complete implementation of the classic Snake game, but with a twist. The snake plays itself using intelligent pathfinding. Every move is calculated using algorithms to find paths to foot while avoiding its own body. Look at this. The snake uses smart pathfinding to navigate the 8x8 grid. Most of the time it finds great paths, though like any algorithm, it can sometimes get into tricky situations. It's fascinating to watch how it makes decisions in real time. But here's the coolest part. When it wins, by filling the entire screen, it celebrates with these amazing light shows. 8 different animations that make every victory feel special. Now, you might think controlling 64 LEDs would be complicated, but that's where the magic of the Max 7219 comes in. Instead of needing 16 pins to control an 8x8 matrix, we only need 3. 3 simple connections: data, clock, and chip select. That's it. The Max 7219 automatically handles all the heavy lifting. The multiplexing, the current control, even the memory to store what should be displayed. This is a perfect example of choosing the right components. Good hardware design isn't just about making things work, it's about making them work elegantly. But hardware is only half the story. Now that we've got our display sorted, let's dive into the brain of this operation. The software architecture. Behind that smooth gameplay you saw earlier, we have 3 key components working together. First, our data structure. We represent everything as simple coordinate points. The snake is just an array of these points, with the head at the front. Clean and simple. Second, our collision detection system. Instead of checking the entire snake array every time, we maintain a Boolean grid that instantly tells us if a position is occupied. This makes the collision detection much more efficient. And third, our movement system. Here is where it gets clever. We don't actually move each body segment. We just add a new head and remove the tail. The snake appears to move, but we're really just growing and shrinking it strategically. Now, having a snake that can move is one thing, but move intelligently? That's where things get really interesting. Meet the star of the show, our pathfinding algorithm. This is what transforms our simple moving snake into something that can actually think ahead. We use something called breadth first search, or BFS. Think of it like ripples in a pond. We explore every possible move one step at a time, in perfect expanding circles. Imagine you're in a maze looking for the exit. BFS is like having a systematic search party that checks every path at distance 1 before checking any path at distance 2. It's methodical, it's thorough, and it guarantees the shortest path. In our snake game, this means the snake usually finds good routes to foot. But here's the clever part. It knows its own tail will move, so it doesn't count that position as blocked. It's planning ahead. And here's a smart design choice. Food never appears in the corners, which helps avoid awkward positioning situations. So we've got intelligent pathfinding working with smart data structure, but how does it all come together in the actual game? The game loop itself ties everything together beautifully. Every cycle, find the path, move the snake, check for food, grow if needed, and update the display. But what makes this addictive is the progressive difficulty. Each time the snake wins, the next game runs faster. It's like the snake is getting more confident and more aggressive. And when it reaches maximum length, that's when the real magic happens. Because this is where we go from functional to fantastic. Eight different victory animations, each one unique and satisfying. We've got expanding boxes, moving bars, random sparkles, diagonal wipes, bouncing dots, border chases, and even a pulsing heart. Each victory feels different, keeps you watching. This isn't just eye candy, it's thoughtful game design. The unpredictability keeps the experience fresh even after multiple wins. It's the same principle that makes games engaging. Speaking of what makes all this possible, let's take a moment to appreciate the hardware hero we mentioned earlier. The Max 7219 display driver, the hero making all of this visual magic possible. This little chip is doing some serious heavy lifting. It's constantly scanning through all 64 LEDs thousands of times per second, so fast that your eyes see them as continuously lit. Without this chip, our Arduino would spend almost all its time just keeping the lights on. With it, the Arduino can focus on being smart while the Max 7219 handles being bright. This is perfect example of system design, using specialized components to handle specialized tasks. The result is cleaner code, better performance, and more reliable operation. Alright, enough theory. Let's see all of this working together in real time. I'm gonna run through a complete cycle so you can see everything we've discussed in action. So, what have we built here? More than just a game, really. This project demonstrates professional level embedded programming, intelligent algorithms, and thoughtful user experience design. While the initial concept and vision were mine, I used AI assistants for the majority of the programming, and then I spent time troubleshooting the AI generated code as usual and tailoring it to what I had in mind. This project shows how AI can be a powerful collaborator in bringing creative ideas to life. We've covered data structures, algorithm design, hardware interfacing, game theory, and visual design, all in one compact, engaging package. But the best part? Everything we've discussed is accessible to anyone willing to learn. The components are cheap, the concepts are fundamental, and the results are immediately satisfying. This Arduino Snake game isn't just a fun project, it's a masterclass in how to approach complex problems with simple, elegant solutions. We've seen how choosing the right algorithms can make difficult problems trivial, how good hardware design amplifies software capabilities, and how attention to user experience transforms a technical demo into something genuinely engaging. If you enjoyed this deep dive into intelligent game programming, smash that like button. It really helps the channel grow, and if you want to see more projects that combine classic concepts with modern implementation, hit subscribe and ring that notification bell. I'm already brainstorming the next project. There are so many fascinating directions we could explore with electronics programming and game development. Whatever it ends up being, I hope it'll be just as engaging as this one. Thanks for watching, keep building, and I'll see you in the next video.